Good morning, namaskar, and welcome to the course once again. In the last few lectures, we discussed about various concepts involved in risk analysis. We studied few key terms such as additive probability, multiplicative probability, expected values, and measures of variance. In this lecture, we are going to start with a new topic that is known as simulation. You will find simulation as such has a lot of application in the context of civil engineering. Even in the case of economic decision making, you will find it has got number of applications. So, straight away we move to the philosophy of simulation. We will try to understand what are the advantages associated with simulation, what are the drawbacks or limitations of simulation, and we will illustrate you the concepts of simulation with the help of few small examples. Now, if you see as far as simulation is concerned, it basically imitates a real world situation in terms of mathematics. It studies its various properties and the operating characteristics. Then subsequently you can draw conclusions and make action decisions. Now, coming to the advantages of simulation, you will find that it is very straightforward and flexible. So, these are the two keywords, straightforward and flexible. Now, some of the recent advances that have taken place in the context of simulation software, it has made the simulation models or rather modeling very easy to develop. You can carry out the analysis of even large, very complex and real world situations. You can answer what if questions using simulation. We will see in our examples. Further, it does not interfere with the real world system. You can study the interactions among variables associated with your simulation problem. You can carry out the time compression exercise. You can also include the real world complications as we will see subsequently. However, you will also notice that simulation also has certain disadvantages. For example, you will require long and expensive development process, especially for the complicated problems. One of the major drawbacks of simulation is that it does not guarantee you an optimal solution. So, whatever solution that you obtain using simulation, they may not be optimal. Now, the simulation requires managers to generate all conditions and constraints of real world problem. And another disadvantage, you will find that every simulation model is unique in nature. So, these are some of the disadvantages of simulation. Now, there are different types of simulation. Monte Carlo simulation is one very widely used simulation methods available to us. We can carry out Monte Carlo simulation for solving our problem using these 5 steps. So, step 1, what we do is we set up a probability distribution. How do we do this? Is by virtue of collecting a large set of data from our past experience and from our past knowledge. Subsequently, I build cumulative probability distribution, we will see how it is done. Then we establish an interval of random numbers, we will see what random number means. We generate random numbers and then we simulate trials. After doing all these 5 steps, you can carry out similar analysis for some other conditions, and depending on the answers that you get, you can choose a particular strategy for your problem. Now, we try to illustrate you these particular steps for a number of problems, but before that you may like to know what are the type of problems you can try to solve using simulation. You can carry out the inventory analysis, it could be on a daily basis or it could be on a weekly basis. You can find out the lead time for inventory orders to arrive. You can find out the times between various machine breakdowns. You can find out the time between the arrivals at service facility. You can even calculate the service times. the time to complete project activities, that means you can find this application in your CPM and PERT analysis. You can even find the number of employees likely to be absent from work each day or each week, and in our case we will also try to understand its application in the computation of net present worth. So, to start with, we will carry out the demand forecast of a particular product. Let us say we are into manufacturing some product and the demand of that particular product varies on a daily basis. So, what I have done from my past record, I have captured this data. I find that on 10 occasions I did not have any demand. So, that means demand is 0. On 20 occasions I have a demand for 1 unit. On 40 occasions I have a demand of 2 units. On 60 occasions I have a demand of 3 units. On 40 occasions I have a demand of 4 units, and on 30 occasions I have a demand of 5 units. So, you can see I have a record of 30 plus 40 70, 130, 170, 190 and 10 200. So, I have the record of past 200 days, and from this record I know what is the demand profile. So, you can see demand that on 10 occasions the demand was 0, on 20 occasions demand was 1, on 40 occasions demand was 2, on 60 occasions demand was 3, on 40 occasions demand was 4, and on 30 occasions demand was 5. So, what I do is from this frequency value I can calculate the probability. So, you can find the probability for 0 demand would be 10 by 200. Likewise, probability for 1 demand would be 20 by 200. So, what I do? I can calculate the probability values associated with each of these demands. So, let us say I do it here for you. So, let us say demand is 0, 1, 2, 3, 4 and 5. Frequency is already known to us, 10 here, 20, 40, 60, 40 and 30. So, I can calculate the probability from this data. Demand of 0 probability, it is going to be 10 by this sum is 200 here. So, I can calculate the probability, it would be 10 by 200. So, it is going to be 0.05. For this it is 20 by 200. So, it is going to be 0.10. Likewise, this is going to be 0.20, this is going to be 0.30, this is going to be 0.20 and finally, this is 0.15. Now, you can calculate the cumulative probability values. So, this is 0.05, this becomes 0.15, this is 0.35, this is 0.65, 0.85 and finally, this total probability is 1.00. So, these two steps we have easily been able to do. Now, what I do is I assign random number interval. So, there is a term called random number, I represent it with r dot n dot random number interval. So, there are two ways in which this random number interval can be assigned. So, let us say you know random number intervals, you can generate it with the help of even your small calculator also, scientific calculator also. In fact, the random numbers can be of 2 digit, 3 digit, 4 digit or any number of digits. As far as the interval is concerned, I write it like 0, 1 to 0, 5, this is 0, 6 to 15, 16 to 35, 36 to 65, 66 to 85 and 86 to 00. So, let us try to work it out with 2 digit random number. In fact, in some of the textbook you will find there is a table which gives you the random number. So, I will show you one such table and then we come back to this problem again. So, if you see on your computer screen, this is from one of the textbook that I have taken the random number table, and here you can see it gives you the random numbers of 2 digit. So, basically what is happening in simulation is we are trying to imitate a real world phenomenon, and in real world phenomenon you know that the demand could be random in nature. So, I really do not know whether the demand for my product tomorrow is going to be 0 or 1, 2, 3, 4 or 5, I do not know. So, this I am trying to imitate with the help of random numbers. Random numbers do not appear in any sequence, it does not follow any arrangement. So, you cannot really find any pattern when you are generating a random number. So, in your scientific calculator you will find there would be a button, if you press you will get different numbers at different point of time. So, in the problem solving you can even take the help of your calculator. If you do not want to do that, you can refer to a random number table either of 2 digit or of 3 digit, and accordingly we can try to solve our problems. So, if you look at this particular table, you won't really find that there is a pattern. For example, here you can see the number 52. If you look at the computer screen, you find the first number is 52, then you have 37, then you have 82, 69, 98, 96 and so on. So, you can find there is no pattern at all. So, right now it is 33, the next number is 50, the next number is 88, the next number is 90, 50, 27, 45, 81 and so on. So, basically you will not be able to find any sequence or rather any pattern that, let us say, if right now this number is appearing, the next time some other known number would be coming. No, we are not at all sure, and this is the reason we are saying that this is trying to imitate the real world phenomenon. So, what I do after you have computed the random number interval, we will refer to this particular table and we will try to find out the probability of that particular demand. So, this is captured in this particular slide. Say let us try to do this simulation trial for 10 days. So, let us say we are in day 1. Now, I picked up one random number from the random number table. If you go back, the first random number was 52. Let us say we are going in from this number in this manner. Random number we are referring from top to bottom. So, first I am referring first column, then I will go to the second column, third column, fourth column and so on. So, first number is 52. So, the moment I generated 52, you know my random number interval was like this. If you see here, my random number table, I had already shown you the random number interval is shown in this particular piece of paper. So, I will locate where does 52 actually lie. So, you will find that 52 lies in this interval, that means the demand for that day is likely to be 3. You can see here 52 will lie in this interval. You can see between 36 to 65, any number that comes, we will assume that on that particular day the demand is going to be 3. Now, the next random number is 37. 37 will again come here. So, the demand for that second day also is likely to be 3. Then the next random number is 82. So, now you know the demand is going to be 4 on that day. So, likewise, if you see this table, you can easily find out the daily demand. So, corresponding to 52, my expected daily demand is 3, corresponding to 37, my daily demand is 3, 82, my daily demand is 4, 69, my daily demand is 4, 98, my expected demand is 5, likewise for 96 it is 5, for 33 it is 2, for 50 it is 3, for 88 it is 5 and for 90 it is 5 again. So, you can find in next 10 days my total demand is likely to be 39. So, on an average I am getting 39 divided by 10, which is about 3.9. So, this is how you carry out the simulation trials. Of course, when you are doing it manually, you will not be able to go for 100 trials or maybe 1000 trials. However, using the computer software, you can very easily find it out that the number of trials can be increased, and the more number of trials you are performing, you are more likely to be closer to the real life problems. Now, what you can do is, if I would have taken the expected value of this problem from this slide, I could have calculated it like this. So, for 0 demand the probability is 0.05, for 1 demand the probability is 0.1, for 2 the probability is 0.2, for 3 demand probability is 0.3, for 4 it is 0.2, and for 5 it is 0.5. So, if you calculate this, it would be something like this. So, you have 1 into 0.1, so it is 0.1 plus 2 into 0.2, which is 0.4, plus 0.9 plus 0.8 plus 0.75. So, this is coming to be 2.95. So, the expected value of demand is coming to be 2.95 based on the probability values that we have here. But when we did this trial for 10 times, we are getting the expected value, this we are calling it as simulated daily demand, which is 3.9. The difference is coming here solely on the basis of less number of trials conducted manually. If you try to go for large number of trials, you will find that your 3.9 will come very close to 2.95. So, the more you carry out the trial, the closer you are with the expected value that you have obtained. Just because our number of trials are less, we cannot take any hard and fast conclusion, right. You cannot draw very hard and fast conclusions because the number of trials are very less. That is why this problem you can just understand it for the purpose of illustration only. No hard and fast conclusions you can draw from here, because the number of trials that we did was only 10. Now, if you repeat the trials large number of times, as I told you, the simulated demand would be very close to the expected demand. Expected demand in this case is 2.95, and it will be very close to that. Now, the real benefit of simulation can be derived when we take large number of variables, and that too the problem is very complex. So, we will try to show you the complications when I take the 2 variable simulation at a time, and this 2 variable simulation, let us try to work it out for a generator breakdown problem. So, what is happening in this particular problem is, let us say there is a power producing company which is producing the power based on the generator. Now, let us assume the company has got 15 generator sets, and each of these generator sets are contributing to the power supply. Now, as you know, the power supply is from these generators. The company cannot afford to see that its generators are frequently under breakdown. So, what it has done is, it has collected the data from its past working regarding the time between the 2 breakdowns. Suppose right now there is a breakdown, after how much time the second breakdown took place. Why it is interested in finding the breakdown? Because every breakdown is costing money to the company, because in the event of breakdown the company has to borrow power from some other grid at a cost, and then only it has to supply to its customer in an uninterrupted manner. Now, the company has employed, let us say, 4 workers to make sure that whenever a generator is under breakdown, it gets repaired quickly. Now, these workers are available round the clock. How it has been organized is like this: there are 4 workers in total on the roll of the company. Now, every worker is spending 8 hours. So, let us say in first shift one worker is there, second shift another worker will come, and we are having shift of 8 hours. So, we will find that these 4 workers in a week's time they will have about how many shifts. So, total we require 21 shifts. So, you have 3 shifts per day of 8 hours, that multiplied by 7. So, 21 shifts are needed. Now, the workers have been arranged in such a manner that all the time one worker is available, and the cost of hiring these workers is, let us say, $30 per hour. And if a generator is under breakdown, let us assume that its cost of repair is $75 per hour. Rather, the loss to the company is $75 per hour. Now, based on this, we would like to know what kind of policy the company should follow, whether it should increase the number of workers, whether it should put new generator sets, whether it should try to replace those components which are showing faults on a regular basis. So, these are the kind of decisions that we would like to understand. So, what data the company has collected? It has collected 2 set of data. One, what is the time interval between the 2 sets of breakdown, and what is the time to repair every time the generator is under breakdown. So, from the past experience, the company knows that the generator repair can take either 1 hour or 2 hours, or it could even take 3 hours. So, for that also the company has past record, and the company also has kept a record on the time interval between the 2 successive breakdowns. So, in this particular slide, if you see, this is what is given here. So, you can see the time between breakdowns half an hour. Number of times this was observed was 5. So, that means between 2 intervals of breakdown half an hour lapsed, and on such 5 occasions. Likewise, time between breakdown 1 hour on 6 occasions, time between 2 breakdowns 1.5 hour on 16 occasions, 2 hours 33 occasions, 2.5 hours between 2 breakdowns on 21 occasions, and 3 hours between the 2 breakdowns on 19 occasions. So, you can see the total here is 5 plus 6, which is 11 here, 5 plus 6 plus 16 plus 33 plus 21 plus 19. So, this is for 100 occasions the company has kept a data. So, in the first step what I do is I calculate the probability associated with each of these times. So, the probability that there would be half an hour time between the 2 breakdowns, you can calculate it by 5 by 100. So, you divide this by 100. So, you are getting 0.05. Likewise, you will get 0.06 here, 0.16 here, 0.33 here, 0.21 here, and 0.19 here. So, these are the probabilities. Now, I can calculate the cumulative probability. So, this will be given by 0.05, this is 0.11. How? 0.05 plus 0.06 is 0.11, then you have 0.27, 0.60, 0.81 and 1.0. I can generate the random number interval. So, when the cumulative probability is 0.05, I am generating it like this from 0, 1 to 0, 5. That means, any time I am getting a random number between 0, 1 to 0, 5, I will assume that the time between the 2 breakdowns is going to be half an hour. Likewise, if any number is between 0, 6 to 11, I will assume that the time between 2 breakdowns is 1 hour. Likewise, for this 12 to 27, any number appearing in this range will indicate that the time between 2 breakdowns is 1.5 hour. Likewise, you can interpret it in this interval, you can interpret it in this interval, or you can interpret it in this interval. So, this is how you generate the random number interval. Now, this is as far as the time between breakdowns are concerned, right. Now, this is one set of data. The other set of data that the company has observed is like this. It has observed that the generator repair takes rather 1 hour on 28 occasions. It took 2 hours on 52 occasions and it took 3 hours on 20 occasions. So, you can see the company observed this on 100 occasions. Now, based on this you can calculate the probability that the repair time would be 1 hour. So, it is 28 by 100, it is 0.28, 52 by 100 it is 0.52 and 20 by 100 it is 0.12. Again I can take cumulative probability for this. So, this is going to be 0.28, 0.80. How I am getting 0.80? It is nothing but 0.28 plus 0.52. So, this is 0.80. Now, you add 0.20 in this. So, you are getting 1.0. Now, you can easily find the random number interval associated with this. So, any number which falls between 0, 1 to 28, you will assume that the time to repair the generator would be 1 hour. If the number falls between 29 to 80, you will assume that the time required to fix the generator would be 2 hours, and if it is between 81 to 00, you will assume that the time to fix the generator set is going to be 3 hours. Now, based on this I do one small simulation here and it would be done like this. So, you have to make various tables. The first table I will write the breakdown number, it would be breakdown number, it could be 1, 2, 3, 4, 5, 6 and so on. Then I will generate the random number for breakdown. Then I will calculate the time between breakdown, because the moment you know that the random number is this, I can easily refer to that table and find how much time you will take to see the next breakdown. Time between breakdowns. Okay. I can write the exact time of breakdown, right. Then I can calculate the time at which the repair person is free to begin this repair. Time repair person is free to begin this repair, Then again I can calculate the random number for the repair time. So, once you know this random number, you will be able to find the repair time that would be needed. It would be 1 hour, 2 hour, 3 hour. Then the time at which the repair ends, and the last column we can find out the number of times machine is down. So, let us start with this first one. So, let us say our breakdown number is 1, let us say, and let us say we are starting this simulation at midnight. So, 12:00, let us call it as midnight. So, let us say we are starting the simulation at midnight. Now, the first random number, let us say we are generating it to be 57. So, the moment I have got this 57, the time between the two breakdowns will be 2. You remember from where we are getting this? We are getting this from this particular table. If you see, the 57 here is in this range between 28 to 60, and that means this row you can clearly see the number 57 is falling in this row, and it indicates that the time between the two breakdowns is going to be 2 hours. So, what I do is I write 2 here. Now, you already know from where I am getting this 2, because I generated a random number 57, and corresponding to 57 my expected time between the two breakdowns is 2. So, you remember you started at 12 in the midnight. So, your time of breakdown is likely to be 2:00. That means, at 2 a.m. early morning, your first generator is likely to be under breakdown. Now, at this point of time, since I have already told you that repairmen are available round the clock, so they had no pending work previously. So, they are available at 2 a.m. itself for repairing this generator. Now, we have to estimate how much time the repair person is likely to take in repairing this. So, I will again generate a random number. Let us assume that random number is coming to be 07. So, random number that we have generated is 07. Now, what I do is corresponding to this 07, I will find out what is my repair time. So, I refer to this table. If you look at this computer screen, 07 is coming here in this interval. So, what does this mean? The time to repair is going to be 1 hour. So, I simply write 1 hour here. So, repair time is 1 hour, right. So, when it is 1 hour, that means when exactly the repair would end? It started at 2 a.m. So, it will end at 3 a.m. You understood? So, how much time your generator was under breakdown? You remember, time of breakdown was 2 a.m. and it got fixed at 3 a.m. So, the time up to which this generator was under breakdown, I will write it in some different color and we call it here 1. So, this column is basically the time up to which the generator is under breakdown. So, this is breakdown time of generator. I am writing it with red color. Okay. This is because I do not have enough space there. Okay. Now, I go for second trial. I generate the random number again. Let us see, my random number is coming to be 17. So, now I locate where does this random number appear in my table. So, you can see this random number is 17 and this is falling in this 1.5 hour. So, it is expected that the next breakdown will take place 1.5 hour after this previous one has failed. So, what I need to write here? I will write 1.5 hour here. So, this is 1.5 I will write here, time between two successive breakdowns 1.5. So, remember, first time it had broken down at 2 a.m. So, the next it will break down at 3:30 a.m. Now, you can see the worker is free at 3 a.m. itself, because 3 a.m. itself the repair ended. So, he is available at 3:30. So, there is no time gap. So, the moment he comes to know that the generator is under breakdown, he will rush to that particular place and immediately start fixing the generator set. Now, I again generate the random number. Let us see what is my next random number. It is coming to be 60. Now, if you go back to the table, you will find repair time corresponding to this 60 is coming to be 2. So, when exactly my repair would end for this generator set? 3:30 plus 2 hours. So, this is going to be 5:30. So, how much time this generator was under breakdown? We can find it out by subtracting 3:30 from 5:30. So, because 3:30 it broke down and 5:30 it got fixed. So, you are getting 2 hours, right. Now, in the same manner we can perform the analysis, and the remaining analysis is shown in this particular slide. So, you can see here, now this is third trial. Now, the random number generated is coming to be 36. So, corresponding to this, I find that if you go back to the previous slide, corresponding to 36, my time between two breakdowns is 2 hours. So, you can see it is 2 hours here. So, 3:30 it had broken down the previous generator. Now, at 5:30 another breakdown will take place, and you remember at 5:30 the previous generator was fixed. So, this worker is free at 5:30. So, immediately he will take up this challenge. Now, again I am generating random number, this time it is 77. I find that this time the generator repair will take 2 hours. So, 5:30 plus 2 7:30 it will get over. So, how much time the generator is under breakdown? So, 7:30 minus 5:30, so 2 hours. So, this last column is giving you the time in which the generator is under breakdown, one of the generators is under breakdown. Now, you can see I am going to the fourth trial, here the random number is 72. So, if you go to the 72, it is coming in this range. So, it is 2.5. So, you can write here, it is missing here 2.5 here. So, you remember the last time breakdown took place at 5:30. So, after 2.5 hours means that is 8 hours, this generator will be under breakdown. Now, 7:30 the repair work ended. So, the worker is available to repair this at 8 am. How much time it will take to repair will be decided by the random number that we are getting. So, this time it is 49 and so it is corresponding to 2 hours of repair time. So, 10 am the repair ends. So, here also you find that the generator is under breakdown for 2 hours. Now, you can carry on this analysis. I have done it for 15 trials, and in the 15 trials you find that the number of hours in which the generator is under breakdown is 44. So, if you sum it up for all 15 cycles, you are getting 44. So, that means whatever trial we have done so far, in that trial period for 44 hours my generators are under breakdown. Now, one more thing you can notice here is that towards the end of simulation you can see your generator breakdown time is 11 here, repair starts at 11, fine, no problem. Generator is breaking down at 13, repair starts at 13, generator breaks down at 15, but the repair starts at 16 hours. So, there is a time gap you can see here. So, that means there is a backlog. Likewise, if you see the generator got breakdown at 5 hours and you can see the repair start only at 18 hours. So, that means 1 hour difference, 17 hours it was under breakdown, but repair started at 18 hours. Next breakdown 18:30, but repair started at that is 19 hours. Here 19:30 next breakdown, but repair started 20 hours. Here 21:30 repair it got under breakdown and repair started at 23. So, here also you can see 23 and 1. So, 2 hours gap. Here 1 o'clock it got under breakdown and 4 o'clock repair started. Here 4 o'clock it got under breakdown and 6 o'clock the repair started. So, what you find likewise here 5:30 itself generator was under breakdown, but repair started at 8. So, what you find as we are going towards the end of this simulation process, you find there is a lot of backlog. So, workers are not immediately available to take up the repair work. So, this is the problem, and that is the reason you can find towards the end the time of breakdown is very high compared to the initial ones. So, you can see 4 hours, 4.5, 5, 5, 3.5, 3.5. So much of breakdown hour is occurring here, right. So, the total breakdown time is 44 hours, and what is the total number of hours we have done here? So, if you remember the simulation began at midnight, it continued for next one day and it continued for some more time up to 10 am. So, total we are having 34 hours of simulation, and in 34 hours of simulation of course, we had 15 set of generator here, and that is the reason you can see here that this is the 15 generator sets, we can say DG sets, diesel generator sets, and this is giving you a total breakdown time of 44 hours in a 34 hour simulation. So, what exactly we do from this simulation study? As I told you, the simulation time in this problem is 34 hours. How? You started at 12 hours midnight on day 1 and ended it at 10 am on the next day. So, total of 34 hours simulation, and generators are out of service for 44 hours as I showed you in the previous slide. We also noticed the backlog between the time the generator breaks down and the repair is undertaken, especially towards the end of the simulation. So, if you try to calculate the service maintenance cost, you can see 34 hours of worker service time. This analysis was carried out for 34 hours, and you can remember that workers are available round the clock and they are available at a cost of $30 per hour. So, the total maintenance cost is coming to be, as far as the labor cost is concerned, $1,020, and when it comes to the machine breakdown cost, 44 hours of breakdown and $75 lost per hour. So, that will give you a sum total of 3,300. So, the total simulated maintenance cost of the current system, which is the sum of service cost plus breakdown cost, is coming to be 1,020 plus 3,300. So, which is coming to be 4,320. So, the question is what do we do from here onwards? So, you will find that for the given set of arrangement we are finding certain cost. Now, what I will do? I will change the situation. For example, instead of only this 4 workers for whole 1 week, that means 1 worker present in every shift, I can try to increase 1 more worker, and then I will like to run the simulation again, and then we will try to see whether this has resulted in a lesser cost. Likewise, I can simulate another scenario. What I will do? I will try to replace all those faulty parts which are showing frequent breakdowns. So, what you can see here is that depending on the different arrangement, I am likely to get a certain cost. I am going to choose the least cost out of that, and that is how I will run my production plan. So, these are the applications you can think of simulation in civil engineering context. For example, you may have a large number of concrete production plants at your site. Now, many of the equipment must be failing at regular interval. So, whether it is wise to put more number of workers to take up that repair work quickly, or whether to repair those faulty parts for once for all. So, these are some of the situations we would like to simulate. We will see some more examples of simulation, especially in the context of, let us say, net present worth computation in the next lecture. So, what I will do is, I will quickly summarize what we have learnt in this particular lecture. We started with understanding simulation, we understood its advantages, we understood its limitations, we understood the various steps that we take up in Monte Carlo simulation. You remember, you have to first develop the probability distribution table, then you have to find out the cumulative probability, then you have to have the random number interval. Random number, you can refer it from either the textbooks or you can generate it from your calculator, and you can forecast, let us say, single variable, or you can carry out the simulation of more than one variables. The power of simulation you will realize when your problems are complex and you have more number of variables to be simulated. So, with this we stop at this particular point. Thank you very much.